So we're going to do section 410, which is learning even more about quadratics and their graphs. But before we get started on that application, I wanted to make sure we understood some of the notation. So if this is my x, my independent variable, and this is my y, my dependent variable, and let's say I wind up having a graph of a quadratic that looks like this. The points where the quadratic touch the x-axis, those 2 points are called the zeros of the equation. They're also called the solutions. So if you're asked to solve, what they're asking is solve when the equation equals 0. They're called the zeros. They're called the solutions. They're called the x-intercepts. And they are when the equation, the quadratic, equals 0, because the y value at those 2 points would be 0. Now the absolute maximum in this case, that's the vertex. That's the biggest value the quadratic would have, and it increases until it hits the vertex, which is the maximum, and then it will start decreasing. If I have, I'll give you another scenario. I don't think we have any of these in our class, but let's say this is the graph of my quadratic. All right, so these 2 blue points right here, those are the zeros. Those are the solutions. Those are the x-intercepts. These are all different ways to say the same thing pointing to these 2 points, and those are the values for x where the quadratic function equals 0. In this case, the minimum point is the vertex. And so this function would decrease until it hits the vertex, and then after the vertex it starts increasing. And one thing that is on this graph that was not on the previous graph, where I just didn't go down far enough, is this is the y-intercept. That the y-intercept is the point when x equals 0. All right, because we're going to be learning ways to, we already know how to find solutions. You set the equation equal to 0, and then each of the factors gets set equal to 0. And we also have found some vertices, but we're going to learn even more in this section. All right, so here we have the height of a golf ball in meters can be described by the equation, and they actually give us the equation. They tell us the equation, the height at time t is negative 4.9 t squared plus 23.5 t, where t is the number of seconds after it's hit. All right, so let's continue here. Let's use our calculator or spreadsheet to make a table of inputs. So I'm going to go to my calculator, and I'm going to put this in y1. So in y1, I'm going to put negative 4.9. On our calculators, we use x squareds. It's just the name of a variable. Plus 23.5x. And then I'm going to create a little table here. So I'm going to go to table set, and we're going to start at 0 and go up by 0.5s. 0.5 second, half seconds. Oops. And I didn't hit table. I hit graph. Okay, so if you were able to do that, you see that here are some sample data values. So we have at time 0, it's at height 0. At time 0.5, it's at 10.525. At time 1 second, it's at 18.6. I'm not going to write them all down here. At time 2, it's 27.4. At time 3, it's 26.4. At time 4, it's, at time 4, it's 15.6. And I'll go ahead and put it here, at 4.5 seconds, it's at 6.525, height of 6 feet, and then at time 5 seconds, we go to negative. So this one is not valid. It's already hit the ground by then. But let's go ahead and graph these points. So this is going to be golf ball height. And let's look at time in seconds. So here's going to be 0. So here would be 1 second, 2 seconds, 3 seconds, 4 seconds, and we know by 5 seconds it's hit the ground. And let's look at our height. Our height, 0, 10, 18, 27. Now it's starting to come down, 26. Okay, so I would think 30 is plenty high. 5, 10, 15, 20, 25, 30. All right, so that's good. We'll go. That's 5 feet. Here's 10 feet, 15 feet, 20 feet, 25 feet. All right, so I'm going to put these points 0, 0, 1, 18.6, 15, 16, 17, 18. That's about there. 2, 27.4. 2, 25, 26, 27. There's a 27.4. 3 is 26.4. That's about there. 4, 15.6. That's right about there. And I will go ahead and put this 4.5 on there. 4.5 would be right there, and that's going to go up to 6.5. All right, so if I wanted to connect these, my parabola is basically going to look like that. Good. Now, they want us to find the vertex. Number 2 says find the vertex. Well, there is a way to do that on the calculator, but the way we learn in this class is the x value of the vertex is negative b over 2a. So my formula is my height is negative 4.9 t squared plus 23.5 t. And I'm going to head and just add the plus 0 on the end. The coefficient in front of the t squared is a. A is negative 4.9. The coefficient in front of the t is the b. And then the constant is c. In this particular case, our constant is 0. So the x value of the vertex for this parabola is at negative 23.5 over 2 times negative 4.9. So negative 23.5 divided by negative 9.8 is approximately 2.4. Our vertex is when x is 2.4. All right, so what is the value of the function when, I guess I should have put t here, when t is 2.4? That is negative 4.9 times 2.4 squared plus 23.5 times 2.4. I use negative b over 2a to find the value along the x-axis. Now what I'm trying to find is the second part of the ordered pair. I want to find the height when the time is at 2.4, because that's going to be the maximum height. And that winds up being just about 28.2 meters high. So to the nearest tenth, find the vertex. My vertex is when t is 2.4, the height is 28.2 meters. That's the vertex. So that point is 2.2, 2.4. That point right there. That's my vertex. And explain what each coordinate of the vertex means. Okay, so the 2.4 is the time when the ball hits. As the ball is increasing, ball's going higher, 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 higher. Exactly at 2.4 seconds, the ball is at its highest. And that happens to be at 28.2 meters high. And after 2.4 seconds, the ball starts falling. So that's what that means. The maximum height of 28.2 meters occurs at 2.4 seconds after the ball is hit. Now they want us to find the intercepts of the function. Okay, so that means x-intercepts and y-intercepts.